Hello, dear student friends. Welcome to the lecture of Differential Calculus, and we are studying the chapter of Successive Differentiation. In the last lecture, we have studied Leibniz theorem to obtain the nth derivative of product of two functions. Now, we shall in this lecture we shall solve some problems using the Leibniz theorem. So I have written here these three problems. Now we shall solve these problems which are depending on Leibniz theorem one by one. Now consider the first problem. We have to find out nth derivative of y with respect to x, or dny by dxn, if y is equal to x cube into sin x. So this is product of two functions, x cube into sin x, and we have to apply the Leibniz theorem. Now I shall revise what we have studied, the Leibniz theorem. What is the statement of Leibniz theorem? So this statement we have written, the Leibniz theorem. You see, I shall write here. And it is nth derivative of u into v, and this is equal to n choose 0 un into v plus n choose 1 un minus 1 v1 plus n choose 2 un minus 2 the derivative of u, second derivative of v, and so on, plus it is continued, and last will be n choose n u as it is nth derivative of v. So this is the statement of Leibniz theorem. And now you see here in the first term v is as it is. We have to take the nth derivative of the first function and we keep v as it is in the first term. And in the second term we have to decrease the order of the derivative of u and increase the order of derivative of v. Here it is no derivative, here it is first derivative. Next it is second derivative, and here the derivative order is decreased. So the terms are changing like this, that we have to note, and then we can easily apply the Leibniz theorem. And these are the binomial coefficient. We know n choose 0 is 1, n choose 1 is by the formula of binomial coefficient that we have written last time. It is n, and n choose 2, that is n into n minus 1 divided by 2 factorial, and so on. So these are the coefficients, and these are the terms, how the terms are changing, that we have to note while applying Leibniz theorem. And we now consider solution for the first problem. See, y is given as x cube into sin x. And what should be the, whenever there is algebraic function and trigonometric function, or algebraic function or power function, here algebraic power function, and conventionally this should be the second. So because we know that the third derivative of this is constant, x cube. If it is x to the power m, then its mth derivative becomes constant, and the next derivative of constant will be 0. So therefore we shall select this as second function, so that the derivative will vanish after third derivative. And let, for this purpose, let y is equal to sin x is to be selected as first function, that is u, and v we shall select as x cube. This is our u into v, and therefore the nth derivative of y by using the Leibniz theorem. By Leibniz theorem, we differentiate n times using Leibniz theorem. Differentiating n times with respect to x. Using Leibniz theorem. We have now you see it is y, so nth derivative is actually can be written as dny by dxn, or that we have used this type of notation, suffix n means nth derivative of y. And now on the right side, so what is the first term? You see n choose 0, that is n choose 0, nth derivative of sin x. That is nth derivative of sin x. I shall write like this. And v as it is means x cube as it is. Plus n choose 1. Now n minus 1th derivative of this sin x. So we use this notation. Suffix denotes the order of the derivative of this function sin x, and first derivative of into first derivative of x cube, and plus next term will be n choose 2, n minus second derivative of sin x, and into second derivative of x cube. So we have to continue up to third derivative of x cube, because the third derivative of x cube is constant. So what is the first derivative is 3x square. So x cube has the derivatives like this. First derivative is 3x square. The second derivative is 3 into derivative of x square, that is 2x. So 6x. And third derivative is 6. And what is the next derivative will be 0. So first derivative, second derivative, third derivative. Up to third derivative of x cube we have to write that term. And therefore I shall write the next term as plus n choose 3 n minus third derivative of sin x. Decrease the order of the derivative of first function and increase the order of the derivative of the second function, and write the next binomial coefficient. So that is the way of using the Leibniz theorem. So this will be third derivative of x cube. And what will be the fourth derivative of x cube? This is first derivative, this is second derivative, this is third derivative, and this fourth derivative is 0. So there is no need to write the next term because it is going to be 0. All the further terms will be 0, plus 0, and so on. So thus the remaining terms are 0 and there is no need to write the remaining terms. And thus we have applied the Leibniz theorem, and which is equal to, now we write the binomial coefficients and the derivatives of each function. N choose 0 is 1, so no need to write this. And what is nth derivative of sin x? There is a formula of nth derivative of sin x. Nth derivative of, actually we have obtained the formula for nth derivative of sin of bx plus c or ax plus b. Then that is a to the power n sin of ax plus b plus n pi by 2. This is the formula for nth derivative of sin of ax plus b. And now we use this formula to write the nth derivative, n minus 1th derivative, etc. Each order derivative of sine function. And so this is 1, so or we may write 1 into what will be nth derivative of sin x using this formula. See, a is 1, b is not there, b is 0. So a is 1, therefore it is 1 to the power n. And then that is 1 to the power n sine of ax plus b means angle x. It is only x plus n pi by 2. So this is the first term, the nth derivative of sin x into x cube as it is. Plus, now what about the second term? This is nc1, and we know nc1 is n. What is n minus 1th derivative of sin x? Now from this we can write, replace n by n minus 1. So it is 1 to the power n minus 1 sine of x plus n minus 1 times pi by 2 and multiplied by first derivative of x cube. Now what is the first derivative of x cube? That is 3x square. So I shall write here as 3x square. And so thus we have written this term here, plus nc2. What is nc2? We know the binomial coefficients will be like this, nc2, n minus 1, 2 terms in decreasing order divided by 2 factorial. Likewise nc3 we can write further. So this is n minus second derivative of sine, and that is again 1 to the power n minus 2 sine, using this formula, sine of x plus n minus 2 into pi by 2. And second derivative of x cube can be written from this, that is derivative of this. Derivative is the second derivative, and that we see it is 6x. So thus we have written here the next binomial coefficient. Here because the 1 is having the power, different powers of 1 will be again 1, but we are written according to the formula, and n minus 2 is replaced by n minus 1 is replaced by n minus 2, and derivative of this is written. Now next term is plus next binomial coefficient. Observing this term, we can now write the further term. Next binomial coefficient will be n into n minus 1 into n minus 2 divided by 3 factorial, and this will be 1 to the power n minus 3 sine of x plus, decrease the order of this derivative. So we are writing n minus 3 in place of n minus 2, and this is n minus 3 times pi by 2, and derivative of this is 6. So the further term will be, you can guess, the next binomial coefficient and decrease the order of the derivative, but derivative of this is 0. So next term is 0, and so on. So thus these are the terms, and we have used this formula. So using this formula for derivative of sine, and simplify this, that is the required derivative. Now what is the possible simplification? This is again 1, and that term will be yn, the derivative of y will be sine of x, or we can write x cube first. Algebraic term we should write first, x cube into sine of x plus n pi by 2 plus, now here you see 3x square into n, or 3nx square into sine of, or you may use bigger bracket, and then that can be written as x plus n minus 1 times pi by 2. That is the second term. And next is in the same way. Here you see this 6 divided by 2 factorial is 2, 6 by 2 is 3. So 3x will be the term, and this will be as it is n into n minus 1, or 3 will, I shall write first, 3 into n minus 1 into x, and this term is 1 to every power is again 1. So sine of, we may write the bigger bracket, and then x plus n minus 2 times pi by 2. And so this we have written, and the final term is this one. Here you may observe 3 factorial is exactly 6, so that cancels, and remaining can be written in bracket as n into n minus 1 into n minus 3, n minus 2 into sine of x plus, and it is in bracket n minus 3 times pi by 2. So this will be the answer. This is the nth derivative of the function that we have obtained. So this completes the solution for the first problem. Now we shall consider the second. Now see the second problem. It is given that y is equal to square of sine inverse x. Y is square of sine inverse x, and then we have to prove this result, 1 minus x square n plus second derivative of y minus in bracket 2n plus 1 times x, n plus first derivative of y, and next is minus y square n square y, nth derivative of y is equal to 0. This result we want to prove, given y is equal to this value, and for that purpose, see, we have to get the total derivative order is n plus 2, and therefore for such problems having this type of equation result, then we get the two derivatives, that is y1 and y2, and then we apply the Leibniz theorem to get n plus second derivative. So first we start with this is solution of second problem. Y is equal to square of sine inverse x. Now we differentiate this one by one, first order derivative. Differentiate once. Differentiating with respect to x, we get what is the derivative of y. First derivative we are obtaining only y1, the derivative of y, first derivative of y. And what is the derivative on the right side? That is a square function, so it will be first 2 into sine inverse x into derivative of sine inverse x. We have to use the chain rule of derivative. And what is the derivative of sine inverse x? 1 over root of 1 minus x square. We check this. We have just differentiated this one time, and that is first derivative is equal to 2, a square function, derivative of x square is 2x, like this derivative of square of sine inverse x, 2 into sine inverse x, into derivative of inner function 1 over root of 1 minus x square. Now this we can simplify as we take this term on the left side, or we multiply by root of 1 minus x square, and we get this as y1 into, so this is y1 into root of 1 minus x square. And on the right side we have 2 into sine inverse x. So this is what we have obtained. Now we have to differentiate this again one more time, and then see what before that you may see while differentiating this as it is. So it will be better to square this first, because to avoid this under root sign, and squaring both sides we get now see the square on the left side, that will be y1 square, and square of this term under root goes, eliminates, it will be only 1 minus x square. And the square on the right side, square of 2 is 4, and this is square of sine inverse x. But you see, what is the square of sine inverse x? It is again y, and therefore we write this value as y, and that means we obtain the function equation as y1 square into 1 minus x square is equal to 4y. Sine square of sine inverse x is y. So this is the equation that we have obtained. Now we differentiate this again once, only once. Then we will get a relation or equation in terms of y2. Differentiating again with respect to x. We get. Now here on the left side, see, it is a product. So we have to use the product rule. And product rule we will use like this, derivative of first, second as it is. What is derivative of y1 square? That is by square function, it is 2 into y1 into derivative of y1, that is y2. 2y1 y2 is the derivative of y1 square. Second as it is 1 minus x square into plus. Now first function as it is, we are using only the product rule of derivative. First as it is, derivative of second. What is derivative of 1 minus x square? Derivative of 1 is 0 and derivative of x square is 2x. So it is minus 2x. And on the right side, so this much is the derivative on the left side using the product rule. And on the right side, derivative of 4y is 4 into y. Now we may observe this relation, and in this relation, which is a common term, we can observe here y1 is common on the left side also. And again 2 is also common in each term. So we divide by 2y1. Dividing by 2y1. So we get. So what will be each term now? See, if you divide by 2y1, it remains y2. y2 into 1 minus x square. And next, if you divide by 2y1, that is the negative term, minus 2y1 is divided, 1y1 remains, y1 into x remains in the second. And on the right side, if you divide by 2y1, what remains is 2 only. y1 get cancelled after division, and thus we have obtained this relation. Now you see, this is the relation in terms of second derivative of y, second and first derivative of y. Now we differentiate this n times using the Leibniz theorem. So if you differentiate this n times, nth derivative of y2 will be n plus second derivative of y, and that is in the result. So therefore now use the Leibniz theorem. So these are the steps. We have differentiated once, again we have differentiated once, and obtain the result in terms of y2 and y1. Now differentiate n times using Leibniz rule. Or Leibniz theorem we get. Now we see how to use the Leibniz theorem for this. Again we can consider this as first function and this as the second function, and we apply the Leibniz theorem as in the earlier problem. So the first binomial coefficient is n choose 0, and we may write for this product only we have to use the Leibniz theorem. So that will be n choose 0, first binomial coefficient, and nth derivative of y2, that is n plus second derivative of y, and this as it is 1 minus x square. Nth derivative, you note this, nth derivative of y2 means n plus total derivative will become n plus 2, and second function as it is plus. Now this will be nc0 is the binomial coefficient we have written, nc1 next binomial coefficient, and decrease the order of the derivative, or we may write the binomial coefficients directly, that is 1, n, etc. So decrease the order of n derivative means it becomes y n plus 1, n plus 1th derivative of y, and derivative of this, now we are going to write directly what is derivative of 1 minus x square, that is minus 2x, plus the next binomial coefficient is nc2, n choose 2, and decrease the order of this derivative, it becomes nth derivative of y, and take the derivative of this, that is minus 2, and further term will be n choose 3, decrease the order of the derivative, that is n minus 1th derivative of y, and derivative of this, that is 0. So further terms will become 0, and thus this much is the derivative of the first term, plus. Now it is not plus but minus. Now we have to write the derivative of the second term, that is y1 into x, and that derivative I shall write again in bracket. It will be n choose 0, the nth derivative of y1, that will be n plus 1th derivative of y, and no derivative of x, second, that is as it is x, plus n choose 1, nc1, n minus, or decrease the order of the derivative here, that means it will be nth derivative of y, and derivative of x, that is 1. So this is our next term. So what will the further term will be n choose 2, y n minus 1, decrease the order of the derivative of the first function and take the derivative of second, that is 0. So therefore the next term is going to be 0, all terms will be 0 next onwards, and therefore this much is the derivative of the second function, and on the right side it is only 2, so therefore its derivative is 0. First derivative is 0, all the further derivatives will be 0. So thus we have obtained this equation using Leibniz theorem. Now we shall simplify this, and for the simplification we shall put the value of the binomial coefficients only. So n choose 0 is 1, and therefore the first term is 1 minus x square, that is 1 minus x square into n plus second derivative of y. So that algebraic term we have written first, then n plus second derivative of y we have written. And now what is n choose 1, that is n, and this is minus 2. So minus 2n x into n plus 1th derivative of y. This is the second term. And now what is n choose 2, that is n minus 1 divided by 2, and this is 2. So that 2 cancels and there is minus sign. So I shall write n minus 1 divided by 2 factorial, but 2 factorial is 2 and that cancels with this yn, nth derivative of y. So this is we have written. Now there is minus sign, this is 1, x into n plus 1th derivative of y, that is minus x into n plus 1th derivative of y, and this term is again negative, minus n choose 1 is n plus that is negative because we have here this is whole expression in bracket, so we should note the sign, that is minus n y, and that is equal to 0. So this is the equation we have obtained. Now we shall check whether it is the same as this one or not. We shall see the common term and collect their coefficient of common term. What are the common terms in this equation? This is common and this yn is also common. So the first term as it is 1 minus x square into n plus second derivative. And now you see n plus 1, minus sign is common, x is common. So in bracket what remains? 2n plus 1 into yn plus 1. So minus 2n plus 1 times x. 2n into x. x is also common. x yn plus 1 is common. And minus sign is common. What remaining in bracket is 2n plus 1. x into yn plus 1 derivative. And finally here yn is common. So coefficient of negative sign is again there. Minus, this is minus n square and plus n. So that plus n and this minus n cancels. So only minus n square remains. Minus n square into yn is equal to 0. And we check, this is the same result that we wanted. And thus we have obtained the result using the Leibniz theorem. And this completes the solution for the second problem. Now we go to the third problem. So you should verify the steps that we have simplified. Now solution for the third problem. So here what is the function given is log of x plus under root 1 plus x square, and we have to find nth derivatives at 0. So to obtain nth derivatives at 0, we should obtain the result of like this. That means the result in terms of n plus second derivative of y, and then obtain the derivatives, nth derivative at 0. So we start with this function given, y is equal to log of x plus under root 1 plus x square. Now differentiate this, differentiate with respect to x. What we shall get, that is y. So I shall write this as y1, first derivative. And derivative of logarithmic function is the reciprocal of the function. That is, derivative of log of x is 1 over x. So this will be first 1 over x plus root of 1 plus x square into derivative of the inner function. That means derivative of this. Derivative of x is 1, and what is derivative of root function, that we have to write. Derivative of root of x is 1 over 2 root x. So similarly this will be 1 over root of 2 times root of 1 plus x square into derivative of inner function, that is 2x. We are using the chain rule. Chain rule in the derivative is important, and so that rule is used to write the derivative on the right side. Now we simplify this. This 2 divides 2, we get 1, and we add this term, and after addition, so this term will be root of 1 plus x square plus x, and that cancels with this. So what remains on the right side is y1 after simplification. You should verify this. So therefore y1 is equal to, see, if you take the LCM as root of 1 plus x square, we have to cross multiply root of 1 plus x square plus x, cancel this, and only this remains, root of 1 plus x square. So this is 1 divided by under root of 1 plus x square, that is remaining on the right side. Now we take this term on the left side, and again this can be written as y1 into under root 1 plus x square is equal to 1. Now for simplifying, we shall square it, squaring both sides. So what we shall get? y1 square into 1 plus x square under root goes is equal to 1 square is again 1. So this is the first derivative we have obtained. Now again differentiate this to get the second derivative. So differentiate relation in second derivative, differentiating again with respect to x. So what we will obtain is, using the product rule, derivative of y1 square. What is derivative of y1 square? It is square function 2 into y1, derivative of this by product rule. Derivative of y1 square is 2 into y1 into derivative of y1, that is y2. Check it. And this as it is 1 plus x square. And further, that is into y1 square plus next term in the product rule, y1 square as it is, and derivative of 1 plus x square. Derivative of 1 plus x square is 2x, and derivative on the right side, derivative of 1 is 0. So this is what we obtain. Again we may see what is common is 2y1 throughout the equation or each term, and dividing by 2y1, what we get is y2 into 1 plus x square plus 2y1, we are dividing, 1y1 remains, y1 into x remains is equal to 0. So this we shall get, and thus we have obtained a relation in terms of first derivative and second derivative. Now we differentiate n times using Leibniz rule, differentiating n times with respect to x using Leibniz theorem. We get. Now see, we have to apply the Leibniz theorem for this product, and taking y2 as the first function and 1 plus x square as the second function. And as in the earlier problem, we shall apply the Leibniz theorem. So the binomial coefficient is nc0, and nth derivative of y2 will be n plus second derivative. Furthermore, n derivatives means total derivative order will be n plus 2, and no derivative of this in the first term as it is 1 plus x square. This is the Leibniz theorem here. You see nc0 means n choose 0, nth derivative second function as it is. Next binomial coefficient is n choose 1, and decrease the order of the derivative of first function. So here it is n plus 2. Now it will be n plus 1. You must note the first function is y2. Here it is u, and therefore we have decreased the order from this term to this term we have to write. So here it is whatever the order of the derivative decreased by 1. So here the order of the derivative is n plus 2. So we have decreased by 1 means it becomes n plus 1. And take the derivative of this 1 plus x square. v1 means derivative of this. And what is the derivative of 1 plus x square? It is 2x. And go on writing the next term plus that will be n choose 2. And decrease the order. Observe this term only and write the next term. Decrease the order of this derivative, that will be yn derivative, the nth derivative of y. And what is the derivative of 2x? That is 2. Now what will be the further term? see, whenever the second derivative becomes constant, we stop, because then in the next term derivative of this is 0, going to be 0. So therefore this much is the derivative of the first product, plus now the derivative of the second product, y1 into x. Now that is again n choose 0, nth derivative of y1, and nth derivative of y1 will be n plus 1th derivative of y, n more derivatives order, and into x as it is, plus n choose 1, decrease the order of this derivative. Now this becomes yn. So observing this term only, we have to write the further term, how the terms are changing, that we should note. And derivative of x is 1. So further term will be 0, because derivative of 1 is 0. Whenever the second term becomes constant, we stop writing the terms, and this is equal to 0, because the right side is 0. Derivative of 0 is 0, and thus we have obtained this equation. We shall simplify it, and see, we will write the binomial coefficients. It is 1. So the first term is 1 plus x square into y n plus second. Yes. And next is, now you see, this is 1, this is n, and this is 2n x yn plus 1, 2nx into yn plus 1. And further, this nc2 is, we know, n into n minus 1 divided by 2 factorial. That 2 factorial is same as 2 cancels, and what remains is n into n minus 1 into yn. You note the binomial coefficients, and so thus we have written these terms in first bracket. Now next, n choose 0 is 1, and it is yn plus 1 into x. So that is x into n plus 1th derivative of y, and this is n into yn plus n into yn, and right side is 0. So this is what we have obtained. Now we collect the terms, common terms, yn plus 1, here it is common, and this is single term, separate term, we write as it is. That is 1 plus x square into n plus second derivative of y. And if you collect this, is common, x into yn plus 1 is common. So what remains in bracket? 2n plus 1 into x yn plus 1, means n plus 1th derivative of y. And finally here this is n square minus n into yn, and minus n into yn plus n into yn cancels, so only remains n square yn plus n square into yn is equal to 0. So this is what is the n plus second derivative of y, n plus 1th derivative of y, and nth derivative of y equation in terms of these three derivatives. And from this we shall obtain now the derivatives at 0 of yn. So this is what we have to obtain for this this example, nth derivative at 0. And for that purpose, first we shall obtain, so what is the derivative, what is the function y? Y is this function. So we shall obtain the values of the function and its derivatives at 0. And from this, y is equal to log of x plus 1 plus x square. So that was written, the first step we have written this as, and I shall write this as equation 1. Then we have written the equation for y1, so that I shall write as second. And then we have the equation for y2, that I shall write as equation 3. So these we will select as our equations, and we write now their values at 0. These functions we have denoted by 1, 2, 3. And so this we have used. And finally we consider this as our fourth equation. Now from 1, from 1, what is y at 0? Putting x is equal to 0. We have y at 0. This y is function of x. So actually this is y of x. And that is y of 0. We will write. And on the right side, put x is 0. We are putting x is equal to 0 on both sides. This is y. Y at 0 is written as y of 0. Log of 0 plus root of 1 plus 0 square. And that will be log of, so this is 0 plus root 1 means only 1, log 1. And but we know log 1 is again 0. So y of 0 is 0, or y at 0 is 0 from first equation. From second, from 2, what is the second equation? This one. And we will write y1 at 0. So this is over. From 2, y1 at 0 is equal to, put 0 on both sides, and left side we are writing like this, 1 divided by root of 0 square, root of 1 plus 0 square, and that is root 1, and 1 by 1 is 1. And from 3, you see the third relation, or put y is equal to 0, putting x is equal to 0, not y, x is 0. Here also we have put x is equal to 0, putting x is equal to 0 in third. So what we shall get, y2 at 0 into 1 plus 0 square, that is 1, plus y1 at 0, that we are writing like this, into 0 is equal to 0. See, remember, this is not y1 into 0, it is y1 of 0 and x is 0. So this term vanishes, and what we get is y2 at 0. This is 0 and this is also 0. So y2 at 0 is equal to 0. So these are our first values. Y at 0 is 0, y1 at 0 is 1, and y2 at 0 is 0. Now we will consider the fourth equation. Putting n is equal to 1, 2, 3, etc. in 4, that we shall see the further values of the derivatives at 0. From 4, or in 4, put n is equal to 1, 2, 3. Next, in 4, or from 4 we can write, from 4, putting n is equal to 1, 2, 3, etc. or 4, etc. we get. Now I shall write these values on this side. Put n, first put n is equal to 1 in this. So what we shall get? Or this we shall modify first. Equation 4th we shall modify. Then what will be the modification for 4th? 4th we will write this term on the right side. And then that 4th equation we will be having. So 1 plus x square, I shall write the 4th equation here. 1 plus x square into y n plus 2 is equal to, and these two terms we will shift on the right side, that is minus 2n plus 1 times x into yn plus 1, and that is again minus n square yn. So this is the same equation we have written, and suppose this as 4. Instead of this, we will consider this as 4, and it is the same equation. And now we put x is equal to 0 and n is equal to here. Put x is equal to 0, what we shall get? So here putting x is equal to 0 in 4, we get, first we will do this and then we will put the value of n is equal to 1, 2, 3, etc. So put x is equal to 0. So this is 1 into y n plus second derivative at 0. We are putting x is equal to 0. And on the right side we are putting x is equal to 0, but you see this is 0 means this term entirely becomes 0, because product with 0 is 0, and minus n square. This is minus n square, and this is yn at 0, nth derivative at 0. And so this is our next equation. We will consider this as our equation number 5. This can also be taken as fourth. And now we put n is equal to this in instead of now we put the value of n is equal to 1, 2, 3 in this equation and not the other way. Putting n is equal to 1, 2, 3, 4, etc. in 5 we get. So we have obtained these derivatives, then we have first simplified this fourth equation and then put x is equal to 0. We have obtained this fifth equation, and now we put n is equal to 1, 2, 3 in this equation. So what we will get, put n is equal to 1, that will be y3, n 1 plus 2, that is y3 at 0 is equal to minus n square, n is 1, minus 1 square into y1 at 0. And but you see what is y1 at 0, that is 1. So therefore this will be minus 1 square. y1 is 1. Since y1 at 0 is 1. We have to use the earlier values, so that's why we have obtained this. And now n is equal to 2. So 2 plus 2 is 4. Successively we have put these values. y4 at 0, and that is minus n is 2, 2 square, and n is 2, y2 at 0. But you see what is y2 at 0? It is 0. So therefore this is 0, since y2 at 0 is 0. And now put n is equal to 3. This is y5 at 0. n is 3, y5 at 0, that is n is 3 minus 3 square, y3 at 0. And what is y3 at 0? That is obtained above. So we have to use the earlier values in the next derivatives, next order derivatives at 0. And at 0, that's why we have put x is equal to 0 in each. And that will be minus 3 square into minus 1 square. So minus 3 square, see, remember this negative sign is separate, into minus 1 square. This minus into minus becomes plus, positive. But we will consider that as, we will write that as minus 1 square. Minus 1 into minus 1. And then I shall write this as 1 square into 3 square. But what is this? Is y5 at 0. And further, this y5 at 0 can be written as, in terms of this n we should write, and that is minus 1 to the power, which is 2. I shall write this as 5 minus 1 divided by 2. 5 minus 1 is 4. 4 divided by 2 is 2 into 1 square, 3 square. We have written this purposefully. Now that you will come to know in further steps. What is the next? y6. y6 at 0. n is equal to 4. And this is minus 4 square into y4 at 0. But y4 at 0 is, you see, 0. So therefore this is 0. And so on. And so on. What will be y7? y7 at 0 is, again you see, that means put n is equal to 5. So this is minus 5 square. We are putting n is equal to 5. Minus 5 square y5 at 0. And what is y5 at 0? We may observe this is actually minus 1 square. 1 square, 3 square. So this is minus 1. So it will be minus 1 cube. And that is minus 1 cube. And into now that is 5 square, 1 square, 3 square, 5 square. but this is y seventh derivative. This 3 we want to write in terms of this 7 minus 1 divided by 2. So that is minus 1, 7 minus 1 divided by 2. That is 6 by 2, and which is 3, into 1 square, 3 square, 5 square. Now why we have written this power of minus 1 like this? Now you may observe these derivatives. Now first we observe the even order derivative. What is y2? That is 0. What is y4? It is 0. What is y6? It is 0. So that means if n is 0, the nth derivative at 0 is 0. So even order derivatives are all 0. Now we go to odd order derivative. What is y1? It is 1. What is y3? It is minus 1 minus into 1 square, or that is minus 1. And what is y5? Y5 is actually, it is minus 1 square, means positive it is. It is alternatingly positive, negative. See, y1 is positive, y3 is negative, y5 is positive. This is actually positive. Minus 1 square is plus 1. So it is positive. Y7 will be negative, and minus 1 cube is negative, and so on. So thus these are the terms that odd derivatives, odd order derivatives, positive, negative, and that's why now we have written the power of minus 1. Here in terms of y5 it is minus 1 square, but we have to write this power in terms of this number, and that we have written 5 minus 1 divided by 2, which is again 2. Here in y7 the power is 3, we have written 3 in terms of 7. 7 minus 1 divided by 2, it is the same. So why we have written like this? Because we can write nth derivative here, and so on. So this is, and so on. Now we shall list this. Thus y n at 0. So finally we will write these derivatives together, and that can be written as thus yn at 0. There will be two parts. First, it is 0 if n is odd. N is even. Even order derivatives. Fourth order derivative, second order derivative, sixth order derivative are all 0. And what happens if n is odd? If n is odd, the terms will be like this. So this term you may observe, it is y7. It is 7 minus 1. Minus 1 power is 7 minus 1 by 2. And if it is n is odd, then it will be minus 1 to the power n minus 1 divided by 2. 7 minus 1 by 2. For fifth order derivative, 5 minus 1 divided by 2, and so on. And further you see, it is 1 square. 1 square, then 3 square, then 5 square, and so on. So if it is 7, it is last term is 5 square. If it is 5, the last term is 3 square. That is the difference of this number and this number is 2. So if it is n, the last term will be n minus 2. 7, the last term is 5 square in the product. So therefore, what will be the last term here? For nth derivative, it must be n minus second, n minus 2 square. So this much is the derivative of y. y7 we have written. Can you guess what will be y9 at 0 from that? From this, in the same way, this will be minus 1 to the power 9 minus 1 divided by 2, 1 square, 3 square, 5 square into 7 square. So therefore, if it is n here, then the last term in the product will be n minus 2 square if n is odd. So thus we have obtained the nth derivative at 0, and we have separated these derivatives and written all the results in this single equation. Nth derivative of y at 0 is 0 if n is even, and nth derivative of y at 0 will be of this form: minus 1 to the power n minus 1 divided by 2 into 1 square into 3 square into 5 square up to n minus 2 square, square of n minus 2 if n is odd. So that is the separation of the even order derivative and odd order derivative. And that's why we have written this term, positive negative term, in this form. So but this power is always, because n is odd, n minus 1 is even number divided by 2 is integer. So this number is either positive or negative. Minus 1 to the power of integer power is, or every power is either plus 1 or minus 1. That depends on the power is even or odd. If it is even, then it is positive. If it is odd, then it is negative, minus 1. So this is the answer. You should verify how we have written the odd order derivatives of y at 0. And these terms you should note and verify this. So in this way we can obtain the nth order derivative of a function at 0. First apply the Leibniz theorem, get the result in terms of n plus second order derivative, and then put n successively 1, 2, 3, etc. and obtain the derivatives. While writing these derivatives, use the previous values in the next value and express in a similar form so as to write the general result. So these are separate values, but now if you put n is equal to 1, we will get the first value, that is y1 at 0. We put n is equal to 3, what we will get? This second value, minus 1 square. N is equal to 2, that is 0. N is equal to 4, that is even, it is 0. N is equal to 5, we will get this result. You may verify like this. Put n is equal to 6, that is 0. And put n is equal to 7, we must get this result. So you should check whether this satisfies all the earlier results. And thus we can get the nth derivative of function at 0 in this manner. So you please verify these steps, and so remaining part we will continue next time. Thank you.